Hello and welcome to Innovation Celebration, the show where we celebrate recent advancements in science and technology, the people and ideas that make them possible, and the ways in which they advance human flourishing. I'm Angelica Walker-Worth, and this is my husband Thomas, and he's going to start us off today. On this episode, we are doing an innovation roundup. So our last few episodes, we've been taking deep dives into particular topics, and in doing so, there have been some other things that have happened that we haven't been able to cover. So we're going to do a quick episode this week to cover some of those things.
Sure, yeah. And I kind of want to start with something that gets at that part of our mission where we talk about the people who make innovation possible. And a large part of what that constitutes is not just the people who do the research, but the people who fund it and whose passion for a particular area, a particular field of endeavor, leads them to, start foundations and push projects forward. And a really great example of that is the actor Michael J. Fox, who people will probably know from Back to the Future more than anything else. He plays Marty McFly. But if you watch some of the later films he was in, like Mars Attacks, for instance, you can start to see that his hand starts to tremble. And that's because he was diagnosed with Parkinson's disease. And later into his life, he was still alive, but like later on, that started to get more severe. He's, shaking a lot and has difficulty controlling his movements. But he's been quite an impressive warrior against the degenerating effects of the disease. He still works. He still appears in things. He appeared on Arrested Development and various other things. And so he's pushed back against that quite well. But another sense in which he's pushed back against it is he actually set up the Michael J. Fox Foundation, which has now become the world's largest non-profit researcher into Parkinson's disease. And the work he's done, the work the foundation's done, has actually helped produce treatments that have turned his life around. And that's the thing here is he, as a sufferer of the disease himself, his mindset wasn't I've been hit with this thing, I now have to reel from it. It was I'm actually going to try and change the world so that I can live in a world where I don't have to deal with this as much as I did, and that's actually been the case. He says, I enjoy life more now. I'm more comfortable in my skin than I was 20 years ago. I can sit down and be calm. I couldn't do that 25 years ago. That's the medications, the drug cocktails and therapies that we've been part of. And part of what the foundation has done is in 2011, the manufacturing business magnate Robert A. Pritzker passed away, and he passed away from Parkinson's. And as a result of that, his wife Karen, using Robert's wealth, set up the Robert A. Pritzker Award, which is awarded by the Michael J. Fox Foundation. It's the Robert A. Pritzker Prize for Leadership in Parkinson's Research. And every year the Michael J. Fox Foundation gives $100,000 to the winner of that award to continue their research and develop it further. So that's sort of two successful men whose contributions are going towards fighting the illness that affected both of them. This year's winner of the Robert A. Pritzker Prize was Glenda Margaret Halliday, PhD from the Australian National Health and Medical Research Council, a leadership fellow at the University of Sydney, and she's been doing some research comparing the brains of humans and animals in terms of how they respond to Parkinson's and other forms of dementia as well, the degenerative conditions. And part of her research is she identified more areas of the brain that are affected by it than was previously understood. So in the course of understanding that, we actually realized that the disease affects the mind to a greater degree than we actually previously realized. It's helped her understand the cellular pathways that are part of our response to contracting it. So that's created the opportunities for new ways to intervene and try and slow down and, if possible, prevent Parkinson's at all. And Michael J. Fox has said that they're really steering towards preventative solutions, right? As much as treatments. He wants to try and get to a position where it can be prevented before it even starts happening.
Yeah, that's a rather slow onset disease, isn't it?
Yeah.
Yeah, so one of the things I wanted to cover today really closely parallels that story in two respects, both the successful man who wanted to, who's using his wealth to help the world, and somebody who's been personally affected by a disease, going on to make a huge difference in that. So the specific innovation is a device for monitoring glaucoma at home. And so glaucoma is a disease that affects your eyesight and your eyes, and if it's not treated, it can cause blindness, and there's no cure for it as of right now. So major issue. And so there's a lady in Singapore by the name of Kelly Yu, whose father got glaucoma, and she watched him for a couple of years go back and forth to the doctor's office and have these really uncomfortable appointments because they have to monitor the progress of the disease so they can adjust the treatment accordingly.
Right.
And they have to get what's called an IOP, an intraocular pressure, so the pressure inside your eye.
Yeah, as opposed to extraocular if it was outside your eye.
Yeah. Right, yes. So intraocular pressure to figure out how the disease is progressing. This is really the only way to measure the progression of the disease that's with any degree of accuracy. And up until now, you had to go to the doctor to do it. But Kelly Yu said, no, I think we can do better. Mm-hmm. And so she and a couple of other people developed what they've named HOPES, the Home Eye Pressure E-Skin Sensor. And it's basically just a glove that goes on your index finger, and you touch it to your eyelid, and the sensor on it sends the IOP to an app on your phone, which you can then send to your doctor, obviously. And so in doing so, obviously, they had to develop the app and the AI, and they also had to develop the sensor for the glove.
Not just that, but you had to have smartphones first.
Right.
That's done so much for health tracking and all that. Yeah.
But I mean, this specific, what you and her team did was these three things: the app, the AI, and the sensor, which is patent pending.
But it just goes to show how all these different technologies feed into each other.
Yeah. Oh yeah, definitely. And this doesn't hurt at all to put the sensor on your finger, But you and her team have won the International James Dyson Award, the international category of the James Dyson Award. So James Dyson is of vacuum fame, the one who, I don't think he invented the vacuum, but he invented the Dyson vacuum, which is like the most commercially viable. And he's invented a bunch of other things.
I think it has a particular way of working that's distinctive.
Yeah, and he's invented a bunch of other things, James Dyson, and he's still alive. So he set up a foundation, which he now chairs, to administer awards for engineering and design solutions to pressing world problems. So there are a number of categories. Like I said, you won the international one with different amounts of prizes that are intended to go to help commercialize the solutions that these people come up with.
So a bit like in my example, you have two people who both, from a personal motivation, put a ton of work into making these sorts of, or a ton of money into making these sorts of things possible.
Yeah, and Dyson said he himself has been through some of these IOPs for, I'm not sure if he has glaucoma or if they're just testing it because he's getting older, but in either case, it's a personal connection there for him. But yeah, he's a very successful man who's turning around and giving his wealth to help solve other problems by incentivizing that kind of work.
Yeah, and I wouldn't want to phrase it as giving his wealth. He's using his wealth to sort of create the kind of world he wants to live in. That's kind of the more moral way of doing it. So I wanted to sort of jump off the medical theme and, well, not really jump off it, but kind of migrate sideways onto something a bit less medical and a bit more commercial, which is cloning. And cloning is something that, I think we're all to some extent familiar with the Dolly the sheep story, which I'll talk about in a minute. But the sort of story of cloning since that is not terribly well publicized. People may not realize that commercial cloning is actually now a thing. And one company that does that, that's trying to push commercial cloning further, is Viagen Pets and Equine, run by a man called Blake Russell. And he's expanded the sort of cloning business into cat, dog, and horse cloning, as well as pigs, cows, and sheep. And he offers these for a couple of different reasons. It's traditionally for racehorses, or even dogs for pets, or dogs for assistance jobs, or all sorts of things. You selectively breed them to try and encourage the right characteristics. So you want horses with obviously fast running and the right senses and that kind of thing for horse racing, or for whatever other roles you might have a horse in, like police horses and things like that. Likewise with dogs, if you want a dog to be able to help somebody with a blindness or something like that, you need to breed for the right conditions. Now, if you have one that's really good for that, cloning that one could be a better way of doing that than continuously trying to breed the right genetics generation by generation. So that's the sense in which it makes a lot of commercial sense. Is you can intervene more directly to encourage the right genes for certain purposes. And it's also just a way of expanding numbers, for ranchers and things like that. If you want, more of them than traditional breeding allows. But you can also gene edit cloned embryos as well to try and encourage the right quality. So there's a lot of senses in which it's got some quite exciting commercial uses. Also, interestingly, he's turned this technology towards conservation efforts as well, and is actually and that's sort of a complicated ethical issue. But I think many of us, those of us who sort of find nature interesting, kind of want different species to exist just so we can look at them and appreciate them, and he's actually using this technology bred I really struggle to say this, but I think it's Przewalski's horse. It's PRZ or PRZEWALSKI, so I'm not totally sure how to say that. But it's sort of a unique breed, of course, called Kurt.
The horse is called Kurt.
The horse is called Kurt for the San Diego Zoo Wildlife Alliance, and a black-footed ferret called Elizabeth Ann. So, interesting situation of how, human technology is not always destructive to wildlife. It can actually be positive as well. So I think that's just another interesting application of it. But if I go back to sort of the early days of cloning, as I say, people are familiar with Dolly the sheep. That was in 1996. And Dolly was not actually the first cloned animal. That story goes back to 1984. But back then, they were cloning from embryo cells. So they were just splitting embryos, essentially. And that, I don't want to use the word just or make it sound like it was simple, insanely complicated, but simpler than trying to clone from an adult cell. That's what made Dolly really significant, is she was a clone of a fully grown sheep using the cell from a mammary gland of one sheep and the cell from egg cells from another. So it actually led to a situation where a sheep of one breed gave birth to a sheep of a completely different breed. But as I say, that was achieved in 1996. Over the course of the subsequent 25 years, I'm getting old, there's been a lot of development in that, and we're now in a situation where the Korean company Suan Biotech is producing 500 cloned embryos every day. So that's how much this technology has moved forwards. It's had applications that are more varied than just straightforward, the commercial applications I was talking about earlier. It's actually also led to the development of modern stem cell treatments.
Which we've talked about on this show before, a number of stem cell treatments.
Yes, and this isn't the only item today that it comes up in, but specifically the discovery of iPS cells, which is induced pluripotent stem cells. Those are stem cells that can be induced into all sorts of different functions. They have some complications, IPSs. They have a tendency to form tumours, so there's still development work going on to understand how to mitigate that. But they're really useful for regenerative medicine for degenerative conditions. So cloning has actually ended up having a medical benefit for human beings, as well as the obvious benefits of being able to clone animals. I would just sort of put a caveat on this whole thing that we sort of talk about cloning humans in science fiction quite a lot. And Ian Wilmot, who worked on the Dolly project, he said in 2007 that the technique they used, nuclear transfer, may never be sufficiently efficient for human use, and he's also concerned about the ethical implications of that. It really comes down to I think it comes down to a consent question. It's if somebody wants to get themselves cloned, I don't think there's really an ethical problem there. But if somebody doesn't, and there's people out there potentially able to create copies of you, that's more problematic.
But we're not there yet.
We're not there yet.
We're not even close.
We're not even going in that direction, it seems, at the moment. So one other thing as well, sort of on the conservation point, is that they've been looking at the possibility of reviving extinct species using this, which I think is just, again, cool. Like, I think we'd all like to meet a woolly mammoth. It has concerning, if you're going to do that, you're going to run into problems in terms of the environmental differences between when a creature was alive and now. And it's not viable for dinosaurs. If you're thinking Jurassic Park, like the genetic material at the moment isn't really recoverable from that far back. But stuff that's much more recent possibly is. And they actually did it successfully, very briefly, with a Pyrenean ibex, but unfortunately, which is a breed of basically deer that went extinct about 200 years ago, in the 19th century, and but unfortunately newborn infant only lasted 10 minutes because it had instabilities in its lungs and other things. So that didn't go terribly well, but it can be done. That proves that it can be done. I just wanted to make a quick note as well about some of the opposition to this, because the American Society for the Prevention of Cruelty to Animals is pushing for a moratorium on the research, promotion and sale of cloned and bioengineered pets.
Which, the only ethical objection I can think of is just it's not natural, and that's not really a very strong objection.
Yeah, I mean, what harm are you doing by doing the same thing nature already does? The evolutionary process for 500 million years has been perfecting and improving genetics, by accident, but nevertheless, the general tendency towards the right qualities survive and the wrong ones don't. We're intervening and speeding that up and doing that in different ways, which we've been doing throughout the whole of human history by selective breeding. Dogs as they...
Yeah, selective breeding and then gene editing later, but...
Yeah, but the dogs that we see today, the cats that we see today, even the bananas that we eat, we've selectively bred into being that way. Those aren't natural things at all. And we're just taking that to the next step. And, why is it fine when nature does it and not when human beings do it? But... Yeah, but the thing that bothers me more about that is not just the sort of absurdity of wanting to resist this exciting development, but the idea that you shouldn't even research it, when we've already seen that cloning research led to advances that are saving human lives. Just the mentality of wanting to resist research altogether is so bizarre to me. It's going to put the brakes on human progress and send it into reverse, because these things all propel each other. So, if we want to keep society moving forward, you never know what one area of research is going to reveal that helps something else. And so much of what we do on this show is really about pointing out the integrations between those different fields and how they all help each other.
So, moving back into medicine a little bit, though, but still keeping with animals for a bit, a team in Illinois, at a private university in Illinois, have given nanofiber injections to mice with spinal cord injuries, which has allowed them to regain control over their back legs. So, as you guys probably know, as mammals, if we get a spinal cord injury, it's very, very difficult to regain control of whatever part of your body, usually lower body in humans, back legs for other mammals. You usually can't regain control of that. Even with physical therapy, it's very difficult. Most recent figure I could find is that fewer than 3% of Americans with those kinds of injuries regain any significant control.
Yeah, and that's in a country with
decent,
the
pretty good
infrastructure to help. Yeah.
Yeah, and that's still a pitiful percentage of people that are able to regain control over their legs. So with this new treatment, these nanofiber injections, it took 3 to 4 weeks for the mice to be able to walk pretty much normally again. We'll include in the description a link to the article where I found this, which includes a video of before and after. But
that's phenomenal. Although obviously mice have simpler bodies than we do, but they're still really they're still mammals.
They're still mammals. Obviously we need higher dosage, probably a longer treatment time as well. But so these nanofibers are just tiny little fibers that are 1/1000th the width of a human hair. And they mimic the network of molecules that goes around your cells, which is called the extracellular matrix. But that's just, matrix of cells around your...
It's that extra-intra difference we were talking about earlier.
Exactly, yeah. Just the molecules that are around on the outside of your cells. And these nanofibers contain what are called peptides. And peptides promote nerve regeneration. And that's really, really important because your central nervous system, which your spine is, of course, part of, is really bad at regenerating things itself. When something goes wrong, that's generally it, game over. Right. And so these peptides help the nerves regenerate, which they can't really do on their own.
So it's not like your skin or other parts of your body that can repair themselves. Yeah.
Mm-hmm. Yeah. If you get a cut, your skin fixes that usually pretty quickly. If you have a nerve, that gets damaged, it's probably not coming back. Yeah. But these peptides and these nanofibers can help them come back. And so after the 4-week period, the mice, as I said, had regained the ability to walk, and they looked at the neuron extension. So if, neurons are basically what are firing when you're doing any sort of mental activity in your brain, but you also have neurons that extensions that go throughout your central nervous system. And so those, which normally wouldn't be repaired after a spinal cord injury, were repaired. And then scar tissue, which happens inside your body or on the outside whenever you've got a major trauma, injury, or something like that. And it can cause problems in other places as well besides your spine, but obviously in your spine it's a problem. And so the scar tissue was significantly reduced inside these mice after the nanofibers were in there. So that's fantastic work going on, as I said, at a private university in Illinois called Northwestern University, led by a man named Samuel Stupp.
I get confused why Northwestern universities in Illinois, Northeastern universities in Massachusetts.
I think it's in the
Illinois is not the Northwest.
No, I think it's in the northwestern part of the state,
right?
Not the country. But in any case, a private university with a team that are trying something really innovative, and it's come out fantastically well. So next step is obviously to try to test it on people, and the FDA is standing in the way at the moment. You have to get FDA approval to even run clinical trials on people. Of course, people are participating voluntarily, but that's the situation there.
Yeah, it's actually the same problem with the pluripotent cells I was talking about earlier, that because of the complications that they sometimes have, the FDA sees that as a barrier to approving them for a lot of treatments. And it really should be the patient's choice, but we talk about that a lot on here. But so I want to talk about one more really interesting case of, I think, somebody who has a personal interest in something advancing an interesting innovation. And this is a very young man called Matt Krisiloff. And he's started a company called Conception. And they're not Inception, Conception.
As in birth.
Yes. And they're all about trying to turn human blood into a human egg. Now that sounds weird and gross, but really what it is somewhat similar to what I was talking about before with the cloning. It's taking cells from the human body, from the bloodstream, and building an embryo, an egg out of those. So the proper term for this is in vitro gametogenesis. In vitro gametogenesis.
I would say that it's gametogenesis.
Yes, so it's gametes. I mean, are you not sure?
Gametes.
Gametes. There we go. I'm so sorry. My pronunciation is terrible, even for a Brit. But it's about trying to turn adult cells into gametes, which is basically sperm or egg cells. So cells from which you can develop an embryo. Matt Krisiloff was 26 when he started this company, and he didn't know the first thing about biology. I'm starting to feel like I don't at this point, but no, he was going in completely cold. He hadn't even done a podcast about it. He was the director of research at Y Combinator, which is a San Francisco-based startup incubator. So it's one of those organizations that just groups together all these little startups and helps them get funding and access to resources. They were actually an early funder of Airbnb and Dropbox. So all sorts of different fields that they help organizations in. But that meant that he had the connection to tech investors. He describes himself as being well connected to wealthy tech investors. So he was able to work the business side of it and get the money behind. But I say the reason that he wanted to develop this personally is because as a gay man himself, he really wanted to try and make it possible for same-sex couples to have children that are actually their children in a really meaningful sense, and that combine the actual genetics of both parents. He says he was interested in the idea that when can same-sex couples have children together? I thought this was the promising technology for doing this. That's a direct quote. That being said, he's actually going about it. He's actually using the technology he's trying to develop for that purpose, for a completely different purpose initially, which is helping women have children at a later age. Because, as you know, and as I'm sure most of the women in the audience know, as you go past 30 as a woman, your ability to generate viable eggs just kind of goes off a cliff into your late 30s and early 40s, and it gets harder and harder to have children at that point. But the way that, modern civilized lifestyles go, we tend to want to have children later because we want to actually, do something with our lives before that. So, it would be a really good thing if, women are able to not worry about, I need to have a child while I still can kind of thing, but just have it when I'm ready to. So he, his technology that he initially intended for gay couples is also helping, everybody else as well. So I think it's just a really interesting example again of how, doing something for one reason can help a completely different objective at the same time. And part of the reason for that is it's just a lot simpler to do replacement eggs for women than it is to try and create new eggs from male cells. So I'm just going to talk about the company briefly. Conception employs 16 scientists and they've raised $20 million. Some of the financiers behind are Sam Altman, who's the CEO of OpenAI and the former president of Y Combinator, that incubator I was talking about. Jan Tallinn, who's one of the founders of Skype, and Blake Borgeson, who co-founded Recursion Pharmaceutics. So, there's investors from all sorts of different fields there who are putting their money into this. I'll talk a little bit about the process as well. The process uses blood cells from female donors and tries to convert that into the sort of... They're trying to create the first proof of concept human egg from male cells made in a laboratory. Haven't got that yet. They've still got a lot of puzzles to overcome. But he thinks that they're going to be the first in the world to accomplish it in the not too distant future. And he thinks that artificial eggs could be one of the most important technologies ever created, because, as I say, they basically open up childbearing to anybody, older people and same-sex couples. He's not the only person working in this field, though. In 2016, a pair of Japanese scientists, Katsuhiko Hayashi and his mentor Michinoro Sato, I'm not sure about my pronunciations there again, I'm sorry, but I'm trying my best, were the first to convert mouse skin cells into fertile eggs entirely outside the body, using tail clippings from the mouse, induced those into stem cells, and then directed those along the path to become eggs, and then incubated those with ovary tissue. And I'll just do a quick quote from David Albertini, who's an embryologist at the Bedford Research Foundation. He says, "It's not a matter of can you make an egg in a petri dish. Egg cells need to be," he says, egg cells are contingent on their place in the body. They need to be in the right environment. So it's actually about creating an artificial structure that can recreate that process. And that's the same thing that conception are trying to do. It's creating an artificial biological environment in which an egg cell can ferment. So I'll hand back to you for our last item for today.
Yeah, so to finish off, we're sidestepping out of medicine completely, really. We talked in our last episode about water and about hydroponics, which is growing plants without soil. And there's been a really interesting development that was, I think, at first meant for hydroponics, but really I think could catch on and kind of take over plant growing to a large degree. And what it is a gel called HyperRoots that you can grow plants in, and it's 98% water, so very closely relates to our last episode. And then there's 2% of organic matter that provides nutrients and other things.
Got more water in it than most soft drinks.
Yes. Yeah. And so it's created by a company called Proterra Ag, and some of the benefits they found in their studies, as they were testing this gel before they put it on the market, is that you get a higher germination rate, which I suspect is because of the water. You have to have water available for seeds. So sometimes people will tell you, if you have seeds before you plant them, to soak them in water, just because they have to imbibe enough water to be able to germinate. So higher germination rates, which saves you money, your seed's not going to waste. And then better uniformity. These growers who are trying to grow tons of crops at the same time, it's really hard to make sure the conditions are exactly the same in different parts of the greenhouse or the field. And in greenhouse situations, the edge tends to dry out faster, and so you've just got all these different conditions that can put your uniformity at risk, which is a problem when you're trying to grow plants to a certain specification or by a certain time for selling to a customer. So this could help with that. And because it is 98% water, you barely have to water the plants. You do still have to water them for longer crops and for crops that need a lot of water, but it's way less than what you would normally have to do. Another benefit is because this is completely artificial and they're making it themselves, you can specify what nutrient mix you'd like in the gel, which is helpful because some plants are more susceptible to certain nutrient toxicities when you have too much of a certain nutrient, or they're more susceptible to certain deficiencies, like tomatoes are really sensitive to not having enough calcium, things like that. So if you're wanting this gel for your tomatoes, you're going to want a little extra calcium, that kind of thing.
No.
So like I said, they were really thinking about hydroponics, I think, when they made this, but they've okayed it. It's on the label for you to use it for anything from cannabis to vegetables, fruits, flowers, etc. And then when you're done with it, and this is a problem that a lot of the media have for that's currently available for hydroponics, is you have to either clean and reuse your media or somehow get rid of it, and that's not always easy to do. But this gel composts and completely breaks down in like 30 days.
Cool.
So no waste problem there.
Yeah.
So very cool thinking on the part of Proterra Ag, and I think that is actually already out on the market. So at least for wholesale.
So we're not even ending on a, hopefully coming soon. It's already
No,
out.
no, I think it's already out at least for like large growers, wholesale
Cool.
customers.
Well, I think we actually, even though we're sort of going for a, just general roundup, I think we ended up coming with quite an integrated theme out of that episode. Which is, generally the, celebrating the people who make innovation possible and the ways in which all these different things can play off each other. So I started out talking about the Michael J. Fox Foundation and how Michael J. Fox and indirectly, I suppose, Robert A. Pritzker have both enabled Parkinson's research to make massive strides forward. You talked about a new home device for monitoring glaucoma. I talked about commercial animal cloning and the sort of exciting potential of that. You talked about giving mice back their mobility after spinal injuries and how hopefully we could do the same for humans. Then I went on to the conversion of male blood cells into viable embryos, and you finished us off with hydroponics. So thank you very much for joining us, and next week I think I can probably say that we're planning to do our power episode at last, so I hope to see you again there.